Hi, we are Group 21. In this video, we will show you the three techniques we used: the blind search, the heuristic search, and the Monte Carlo tree search. Then we will compare the performance of these three techniques and find out the best model for the Azul game.
Hello, I'm Yujing Liu. In my part, I'm going to talk about our works on blind search BFS. The reason why we choose blind search BFS as a baseline is because it's a basic algorithm and has no previous works on inputs. In our design, every node is a game state, and the following branches are the available moves at that state for one of the player. Player will take turns in each layer. We can explore a new child node onto each move. The cost is accumulated, and if our player is benefited by the move, the cost will decrease. On the contrary, the cost will increase. The goal state will be the node with minimum total cost. This is the illustration of our design. GS is the game state, and different colors represent different players' turns and their available moves. Because Azul has no specific goal state, so our BFS needs to walk through all possible nodes to find the minimum cost node, which is not only memory consuming, but also cause timeout with 1 second time limit. Lastly, because we define the goal state by ourselves, so it might not be perfect. To make some improvements, we set some bounds in our BFS model so that it will only explore maximum 500 nodes or 3 layers, which will bring the time limit to a more practicable value, 30 seconds, for us to compare BFS with other two techniques.
The second algorithm we use is heuristic search. The basic idea of the heuristic search is using a heuristic function to estimate remaining cost. This function is used to provide an informed way to know which node will finally lead to the goal node. In this project, we will use best breadth search, and the heuristic function was set as the sum of the wrong score and best score. The move which has the highest score will be the best move. The strength of this algorithm is that it has a good accuracy and will not time out. Also, it will consider more than one layer. However, the weakness of the heuristic search is that it has a high space complexity and has no training appearance. In order to improve the performance of the heuristic search, we can increase the number of layers we will search.
Hi, I am Cheng and Fan. In this part, I am going to talk about the third algorithm we implemented, the Monte Carlo tree search algorithm. There are three reasons why we choose NCTS. First, the NCTS is an online algorithm. The uncertainty of opponent's move leads to too many states in the Azul boardgame. Using the NCTS could save the computational effort. Second, using NCTS will never time out and always return the best action available. Third, the game properties make it suitable to implement NCTS. The Azul game is perfect informed. States are always visible to all players, and in many cases of Azuls, there are usually multiple equal good moves. The neural network model could not find a meaningful relationship between them, but the randomness of NCTS could. As we could see in the picture, the red node is our agent and the blue node is our opponent. Line represents an action. Due to the uncertainty of opponent's move, there will be multiple possible outcomes after our agent executes one action. We use NCTS with random simulator to simulate all possible outcomes and find the best move. The challenge we face is that, first, due to the low probability of the same state happening, our NCTS agent always explores. Second, the NCTS agent could not learn from experience when it plays more games. Lastly, our agent assumes our opponents select random move and only optimize our own score. In order to solve those challenges, in the future, we could combine NCTS with neural network to let the agent learn from experience. Also, treat our opponent's scores as negative reward to minimize them. Finally, assume our opponents always select the best move for simulation. The evaluation and conclusion. To choose the best techniques, we first use our three agents to compete against the naive players. We found that the NCTS player got the highest score, but the BFS player had the highest winning rate. Then we compete our agents with each other. We found that the NCTS agent win over the both BFS and heuristic. Therefore, we choose the NCTS as our final agent for the tournament. Thank you.